Hello, everyone, to the Cybersecurity Magazine Podcast. My name is Christian Rudolph, and today I'm joined by Professor Ahmed Banafa, expert on IoT, cybersecurity, blockchain, written several books on the topic. But today we're going to focus on blockchain in particular. Professor Banafa, thank you so much for joining me. Maybe to start things off, why don't you give us a quick summary of what is blockchain, what fundamental problems does that technology solve?
Okay, thank you so much for the invitation, and I'm really happy to be with you guys tonight. Blockchain is a software, just to put everything in perspective here. It's basically solving the problem of centralization, where a simple example, I'm going to give it to you to just explain to you what's the difference between the current system we have now and if we are living in blockchain world. If you have let's say an office building and there are 100 staff working in that office, and there's a security guard at the door checking the IDs of everybody who's trying to get in. If I go there, that security guard will have a tablet with names and pictures. If I'm there on that list, on my picture, I can't get in. If not, he or she going to ask me to leave. If I manipulate, if I bribe that security guard, I can get in the building and nobody can question me after this one. I'm inside the building. Now, this is the current situation we have with the centralized system. It's username and password. If you can go around that, you can just get into the system. If we're talking about the world of blockchain, every single staff in that building, the 100 of them, will have a copy of that tablet with names and pictures. So if I'm walking, into the, the first floor or the ground floor, and the first person will look at me and try to check if I'm my name and picture there. If not, they're going to talk to the next person and the third person. And after a few of them, they're going to say, sorry, we don't see you name here or picture, leave. If I try to bribe one of them or convince some of them, it's too late because it's going to go all the way to the fourth and the sixth and the 10th person. So it's a distributed ledger where the information is saved in an encrypted way on a different computers, and those nodes or computers can be distributed all over the world. Censorship cannot work with it, and also it's immutable, means once you have it, it's just, you write it there and you cannot change it. There's no way to change the information. They design it that way to make sure that it is secure.
Understood. Thank you for that. And the whole topic of decentralization is quite crucial for blockchain. Now, are all blockchains created equal? Is there one type of blockchain that is sort of owned by everyone, or are there different ways of operating these ecosystems?
An excellent question. There are actually multiple types of blockchain. There is the public blockchain network, which is the Bitcoin, the Ethereum, where you can join them. There's no conditions for you to join. And there is private. The private one is that you build it yourself. Companies like IBM, for example, Microsoft, Amazon, they will offer you something called blockchain as a service, where basically you go to them and tell them, I would like to have a blockchain because I have some important documentation. I will make sure that this is be safe. And you decide the size of the network, 1,000, 5,000, 10,000 computers. And they have a protocol how to do that. One should be separated, has to be in different geographic areas. And there is a hybrid, which is, you can use the public blockchain for transactions, for communicating with the clients. At the same thing, you can keep the information on the private blockchain. And there's a fourth one, which is called federated. Federated is when you have the government, for example, you see the State Department in the United States, or the Department of Justice, they have their own blockchain. This is federated. How can they communicate with each other, given that each one of them have their own, blockchain network?
I see. Okay, quite interesting. Now, you mentioned before that it obviously solves a bunch of issues when it comes to tampering with specific parts of data and trying to spoof certain point of data that has been recorded before. For what type of applications is this technology used already today?
This is an excellent point. When you're looking for security and trust, you look for blockchain. For example, a main example of this one is, which is actually in action, is supply chain. Walmart in 2019, starting 2019, they told all the vendors, if you're not part of this network, which is a network that is developed by IBM called Food Trust, which is a private blockchain, we're not going to do business with you. The whole point of it is to track the food from the farm to the table, or from the farm to the fork, where I can see where this shipment came from. And because everything is automated, the information will be stored in the blockchain, and there will be copies of it, in multiple computers. Instead of having somebody, type the information or write the information from one point to the other, and then there is a possibility of changing that information. And that's going to help in different ways. Number one is, for me, I understand this is coming from this farm. So if I am a person with some kind of ethical, let's say, goals, that I'm supporting the farmers in that country or in that area. At the same time, if we have some kind of, let's say that one of the vegetables or fruits is now become contaminated, for example, and would like to know the source of this, where this thing happened, how instead of shutting down the whole supply chain. And that's what happened when we have like 5 years ago problem with the lettuce, and they shut down. They stopped offering it in fast food, in restaurant, in hotels, and that shut down a whole industry and a lot of farms really suffered. Why don't you can know exactly that this food poisoning happened because somebody bought from this store or from 2 or 3 stores. You can track it back to see the farm. So it's going to help in that sense. So supply chain is an example of this. The other one, the other part of of looking at it, it is used to secure the information for the medical supply. When we have the vaccine sent from one location to other location, each one of the boxes has 2 sensors. One of them is GPS, one of them is temperature. You have to record this to make sure that something stay within the range. And this is all done automatically and uploaded to the blockchain, so nobody can change that one. You can apply this one to a network of hospitals. Talking about the pandemic and the COVID-19, if we have have the blockchain network, and all the hospitals in the world, regardless of the government or the location, are participating in that, the main hospitals, we will know automatically where is the hot area, and the government of that that area of that country cannot suppress the information, because if they stop it in 1 or 2 of the computers, there are thousands of computers still have that information. Then we can talk about so many things. We can talk about it. Given that you're looking for trust and looking for security, the blockchain will be the solution.
Understood. And you mentioned obviously the issue of health and potential use cases in the health industry. Obviously, the last 2 years, there's been quite a lot of discussion about technological solutions or technological aids to sort of counter a pandemic like the one we're living through at the moment. And you see multiple countries around the world, coming up with multiple different solutions to either track movement of people, track the spread of the virus. How do you see blockchain potentially play a role in that in some, in the next pandemic? Is blockchain the right tool to help with that?
The blockchain plus the concept of smart contracts. A smart contract, again, is a software. The smart contract is a concept that's created by the Ethereum network. The whole purpose of a smart contract is you trigger action based on certain parameter. Translation of this is, just remember the example we have about the network of hospitals all over the world, the main hospitals that will report any kind of a spike in cases. If we have a smart contract, that written to say, if the cases is more than 1,000 cases in city X, then an alert will be sent all over the world, and they will quarantine that area and they will isolate that area instead of dealing with the pandemic or this virus that crippled the whole planet. And I mean, until now we're still going up and downs with it, and thanks God we have vaccines, but at the same time you have to have the vaccine card, and you have some people against that. You have people thinking that there's a chip inside that vaccine, all these kind of crazy stuff there. The smart contract itself will trigger this alarm, and that will be sent all over the world. So they're gonna, and then it's easy for you to just stop it at the origin instead of knowing about it when it is in your backyard. This is just an example of how to deal with it from the beginning.
Understood. Are there any privacy implications to that? Obviously, me myself, I'm from Germany, and I know that in Germany the debate about privacy, privacy protection, and how your data is being handled is always quite hot. So, if my data is being recorded in a blockchain immutably, what does that mean for privacy?
Okay, that's a good thing, because privacy is one of the pillars of blockchain. Everything is encrypted. So, and with the encryption, you have your own private key, and there is the public key where you can give it to people that can send you information or send you money or communicate with them. There is no way for anybody to use your information without your permission. And that is because you own that information and it's encrypted. There is no way for them to get that information without your consent to use that information. And that is a key thing for GDPR, for CCPA here in California, all of these things. Because the concept of blockchain is created to protect, secure, and make sure that nobody can modify the information for their own benefits here. If somebody looked at a block, they're going to see just numbers. They're going to see those numbers and letters, which is the encryption of the data itself. Without my permission, they cannot see that information. They cannot see what's inside it, what's my health, what is my information, what's going on with it. Here's a good example for this to one of the projects that I was involved with. It is whenever you go to a doctor or you change your doctor, usually there is a list of information they ask you for it, which is, have you ever been this? It's a long list, right? And so a lot of time people just check and get that information. If you change the doctor, you have to go through the same list. Why don't we just save this information in a place which is secure, and that place where every doctor will be part of that network? If I change the doctor, I'll give them permission to access that information for me and just grab that information instead of wasting the time of making mistakes or going through the information again and again and again. The same thing apply when you buy and sell a house. They check all the background. If you want to buy a house, why don't you have all my information there? Because my my birthday never changed. My social security number in the United States never changed. You're talking about certain thing about me never changed. I mean, my job is not going to change. It's going to add more to it. So this information will be stable and it will be sitting there. You have to be part of the network to get that information with my permission, because I have to give permission to get that information. So this is a solution for the transformation of information and sharing information, encrypted, unless I give you permission to see that information and use it.
All right. Yeah, I think that's quite important to hear. If you're not following this technology in such detail as you are, I think a lot of people could get the impression that blockchain isn't that only used in Bitcoin and isn't that only used by criminals, but it's good to hear that there are such really, really productive uses for this kind of technology as well. I want to go into a little more detail on the security and privacy aspects of blockchain. You mentioned the information is protected and that privacy and security is one of the core design principles. How exactly does blockchain technology guarantee the security of the data that is recorded in it?
It's an excellent question. Number one, it is immutable. That's mean once you enter the information, it's there, and it goes through a technique of encryption called, you're talking about 256, encryption base. When you talk about it, that's a very strong encryption. Yeah, you're gonna need years and years, for the available computational power to get to crack that code. So the encryption is very strong in this sense. And the encryption, the way how they encrypt that information, it's really interesting. That there is, in the technical people who are listening to the podcast, they know what is Merkle tree. It has nothing to do with the chancellor who's done this recently. It's just it's convoluted. You take the information and you encrypt it, and then you combine it again, you encrypt it, you combine it again, you encrypt it. So it's like a leaf, one inside there is just getting through the process of getting that information and unfolding the information. It's going to take a tremendous computational power. One important thing about the blockchain is that they make it so difficult for people to get the information and decrypt the information to a degree where they just give up. I mean, look at the example of the building, the office building. I can convince 1 or 2 or 3 of the staff. What about the other 97? I can't do it, because by that time everybody knows that I'm not supposed to be here, and then they can just kick me out of the building. One example I give it to the student is why people go and rob the banks, because the money is there, right? That's the general term. So let's say that somebody decided to rob the bank, and hopefully nobody is listening to this have this idea, but they went to the bank and they say, I'm going to go there and get the money. If that person went to the bank and saw snipers at the top of the building, 5 or 6 cars, police cars surrounding the building, SWAT team outside the building, he can go in and try to rob the bank, but you know what's going to happen? That person could lose his life or go to jail for a long time. So it's not just, they make it so difficult for the criminal to decrypt the information, which is like something called SHA-256, that's the name of it, secure hashing algorithm 256, to get into that system. The degree they say we cannot do that, it's impossible for us. And the privacy is protected by the private key, and the private key is a long number that you only the only one who have that information, where you can give permission for whoever want to access your account by say, yes, I'm okay with this one, that person to to get that information.
Understood. And right now, looking at some of the other technological advancements that are coming along in recent years, there's obviously a lot of talk also about quantum computing, what kind of threats that poses against specifically asymmetric cryptography. How does that affect blockchain implementations?
Okay, very good point. We're talking about quantum computing. I just finished my 3rd book and it's talking about quantum computing and other transformative technologies. So I explain in details the concept of quantum computing, and specifically in one of the chapters, I was talking about something called quantum supremacy. Quantum supremacy means a calculation that's supposed to be done in 10,000 years, you do it in 200 seconds. And this is what happened in 2019. Google announced that they reached the quantum supremacy, and they done that one with 53 qubit, which is the measurement for the quantum computing. And that's a calculation that's supposed to be done in 10,000 years. They did it in 200 seconds. The current encryption we have in the internet, which is RSA, and the encryption we have, that secure the internet communications, secure the banking we are doing. In order for you to get to the level where you can crack that encryption and get that information, you need a minimum 1,500 qubit. We are, as we speak, at 120, 130 qubit. So we are far away from that, but it's exponential. And when you talk about exponential, it could be 200 tomorrow. The time frame for quantum computing is about, something like 5 to 10 years. 10 years to be commercially available. You can go to stores and buy a quantum laptop. 10 years is to have it in a enterprise environment, so people can say, I can use this one for analysis, use this one for chemistry or for biology or all these kind of things. So the how to deal with this when it comes to blockchain, we have to think about quantum blockchain. In this case, we have to think about the cryptography, about the quantum cryptography, and how can we change that to to something which is the quantum computer cannot deal with it, which is cryptography at the level of the quantum, using the quantum physics to create the encryption, and that's going to be the solution. And this is a few years from now. It's not going to happen soon, and and there's a lot of technical difficulties to do something like that until we get to that level. So if we hit the 1500 quabit, now that will be the alarm. Now the 2000 quabit is the whole world is open, that you can see all the communication in the world.
Understood. Okay, so there's still some work to be done, as I see. Yeah. Maybe looking aside from this very theoretical issue at the moment, still theoretical, to something more practical regarding blockchain implementations that we have today. You mentioned earlier that supply chain might be one of the areas that the blockchain helps to secure. But what about the supply chain of the blockchain implementations? So if you look at blockchain implementations today, what organizations are developing this kind of software, and how do they ensure security for something so fundamental to those different applications that we mentioned earlier?
And companies like IBM, Amazon, and Microsoft, they have the skills. They have the engineers who design the blockchain that will be integrated, excuse me, with your software, so it can grab that information, basically read the barcode, read the signal coming from the GPS or coming from the boxes, and then register that one in the blockchain. This is how they have, because remember that blockchain is a software, and that software will be integrated with a user interface, with a backend that will communicate with the rest of the system, so they can get this information and have it ready. Now, the other side of the story, just to make sure that it's not just limited to the supply chain, identity verification. There's a famous project by United Nations in Jordan. There is the Syrian refugee camp. It's a very famous one. There's a lot of articles written about it, where they left their country under horrible situation, and now they have no IDs. Now they have kids born in the camp. How would you identify that? So they came up with this project where everybody have to submit their fingerprint and their biometrics, and this will be stored in the blockchain. And of course, it's going to be encrypted and secured by the UN in different locations. If you want to go and ask for help, they scan it, and you cannot ask for help twice or 3 or 4 times. So you're not going to take the food that it is distributed to other people. If you want to leave the camp because you have an opportunity somewhere else, they give you documentation based on that information. So this is another way, which is verification of identity, which will make it very independent of somebody. You pay them so they can sign it for you. I can give it to you. The other one is for the degree. MIT is one of the leaders when it comes to degree verification, because we're not talking about somebody in Boston or in Massachusetts. Talking about people who go to the MIT and then leave the country and go somewhere else. How can I verify the degree? I have to mail it, I have to fax it, I have to email it, and still the question about people just made up those kind of informations. So if the employer is part of a private blockchain created by MIT, that employer can get a digital copy of the certificate, of the degree of that student from MIT. And that one is verified because the information is in the blockchain. The only organization who entered that information is MIT, and MIT entered it, and it has multiple copies, so nobody can change it. And you can imagine how much and how far you can go with this kind of verifications. I don't need passport, I don't need ID, I don't need everything is there in that database, and that database can be verified by looking at an app I have or by having my biometrics, and then I can get the information right away.
Hearing about all these different use cases that are potentially to benefit from blockchain, Are there any applications where you see, or where there are challenges, where blockchain might prove challenging to support these kind of applications?
The cryptocurrency is one of the actually the blockchain is a victim of the cryptocurrency because the Bitcoin is overshadowing the applications of the blockchain, and its reputation of that the cryptocurrency is actually gave the kiss of life to the ransomware criminals. I mean, in the past, if somebody attack a website or attack an organization and encrypted all the computers and ask them for money, it's either wire this one to an offshore account, meet me at the corner, leave the cash under the post, under that chair, under that and that's old style. Now what are you going to do? Just send me that crypto, that Bitcoin, and I can I can cash it outside the United States, for example. And that was really overshadowing this. We talk about the cryptocurrency without understanding the underlying technology that it is powering the Bitcoin itself or the Ethereum or any other cryptocurrency, because you are using the blockchain to make sure that the information that you are processing stays there, nobody can change it. And that's really backfire big time at the blockchain. I remember, I started my interest in the blockchain in 2017 when I wrote an article that MIT Technology Review picked up that article and published it. Since then, it's been, read and downloaded over 1 million times. So the minute I mention the blockchain to anyone, whether it is Bank of America, Wells Fargo, or all this one, no, this is cryptocurrency. We don't deal with this. It's unregulated. It's not. Until this moment, we have the same fear of this. And this slowed down the spread of the applications of the blockchain and give it a challenge. Another challenge is the skills. How many engineers we see now who really graduated with good knowledge of cryptography, blockchain, understanding how to build it, understanding how to test it. We don't have that many. The universities cannot even catch up with the demand we were looking for when it comes to the crypto, to the blockchain. They look at it and they say, we don't have enough, engineers that can help with this. One last thing I want to talk about it is the blockchain itself. When you talk about it, it's not just technical. We need lawyers and attorneys and paralegals because of the smart contracts, because the smart contract is one way for us to have condition on the blockchain. If I want to buy a car from you, the money will never transfer unless I receive the car, the GPS of the car, and I'm okay with it, and I press something, and that has to be in the location where we met. And I place it in a certain way, that I'm not under duress and all these things. How can I translate this one from the language, legal language, into a software? So you need attorneys, you need paralegals. It's a new branch for the legal, profession to deal with the smart contracts, and that's another field that opened for for people when it comes to the blockchain.
Okay, so a lot of new skills needed, a lot of skills in order to unlock these new opportunities. If you look ahead at the development of the blockchain or the whole ecosystem, really, as you just mentioned, it's not just technology. Where do you see the blockchain in, I don't know, 5 years from now, and what kind of development is necessary to get there?
It's the blockchain as a service, where you're going to find a lot of the companies, the big companies, will offer that to everybody, to make sure that the important documents, the important information will be secure. An expansion in sectors like the health sector is important. An expansion in the financial sector also is an important one. An expansion in the educational system or the educational sector is also an important one. It's a matter of going from show me, how the information or this technology is, is developing or is working, to let's try a pilot program and see how this pilot program will help us understand that. So it's according to McKinsey and Co., it's still in the beginning of the growth cycle. So we're talking about another 5, 6, 7 years before we can see a spread of this that will have cases or use cases where people can have best practices. They can understand the mistakes, can help with the different examples. It's a young technology, and this technology is here to stay. It's just we would like to pull this technology from the shadow of the cryptocurrency and the Bitcoin, because that one is easy money and everybody's talking about it. This one is the future, building the infrastructure and making sure that this infrastructure is available to help in supply chain, in education, in health, in financials, everywhere.
Yeah, it's definitely worth getting into it and learning about the blockchain. I'm hoping that our listeners took away some information about it and really learned about some new aspects of the blockchain. Just before we close out, if our listeners want to learn more, where should they go? What would you recommend?
I mean, one thing, they can read my book. It's Blockchain Technology and Application. It's written, for everybody. It's not a highly technical book. You can understand it. And also you can follow me in LinkedIn, and I post a lot of information about blockchain, or on Twitter, and I follow and I share the same information. And they can contact me if they need more information. I'll be more than happy to give them the resources.
Absolutely. Please check out the LinkedIn page, the book. Once again, Professor Ahmed Banafa, thank you so much for your time today. And thank you for tuning in. Until next time.
Thank you.